Question 3 on the practice exam is about testing two populations. In this case, we're testing the speed of play at a golf course in 2005 and 2006. And we see here that they want to know if there's a difference of speed in play between the 2 years. So this word here, the difference in speed, not whether it was faster or slower, is a key clue for us in determining what type of test this is, one-tail or two-tail. We'll talk about that in a minute. So they want to conduct the appropriate hypothesis test using alpha of 0.10. And we're assuming that the playing times are approximately normally distributed with equal variances. Okay, so that means we can use students T. All right, and so we're given some information here. All right, in the table. And so the first question is what type of a test it is. Okay, so I'll get back to what I was just mentioning there about difference. They want to know if there's a difference. Was it faster or slower? So, of course, when we hear that, we should think, well, it could be faster or slower, meaning there's going to be two rejection regions in either end of the distribution here. So the upper and lower tail. So they weren't saying they were saying was it faster or slower, then we would do something different in the alternative hypothesis. But in this case, we are saying what is the difference? So it could be faster, could be slower. So we've got a two-tail distribution, a two-tail test, and so we need to pick the appropriate hypothesis statements. The statements here are all formulated correctly, or in that we're dealing with mu. So each of the alternatives to choose from show mu. So sometimes that's something to keep an eye out for. If it might say x bar is greater than in the hypothesis statements, that would obviously be false. They also have to be stated in terms of the population parameter. That's all okay here, but there is only one set of statements here that is two-tail, and that is right here. Okay, so you've probably already picked that out as I was talking, but those are our appropriate statements. And then the next question is it a one-tail or a two-tail test, or upper, lower, or two-tail? We've already talked about that. It's a two-tail test. Now, in this case, in this test, problem, we are given the T of alpha. T of alpha is 1.6686. Okay, and that's not part of the table. That's why it's given to us here. And the decision rule then in a two-tail test would be if the test stat, if I could spell test stat, is greater than 1.6686 or less than negative 1.6686, reject the null, otherwise do not reject. Okay, so again, this would be negative 1.6686 here, and over here would be 1.6686 if you're looking at it on this. So anything above that or anything below that, we will reject the null. Okay? All right, so what's the next part of the question here? The pooled standard error, so they give the whole thing here is 5.13. So if you look over here at this equation, what we're given here is that whole value is 5.13. And I mentioned to you in class, I'm going to give you this, the result of this. I'm not going to make you calculate that. So that whole denominator we are given. All right. So now the other thing I'll point out, if you recall in our test for our purposes, the difference between mu1 and mu2 is going to be 0. Okay, it's always 0 for us, for our class's purposes. Let's make some room here to finish the problem. All right, so we've got that information. So now what we really need to do is calculate the test statistic using this equation right here. We already know the denominator is 5.13. And then what we need to do is get the difference between x bar 1 and x bar 2. Okay, so that's going to be 225 minus 219 minus the difference between the two population mu's, okay, is 0. And this is T that we're calculating, the test statistic. So our result then is going to be 6 over 5.13, which is going to be 1.17. Okay, so 6 divided by 5.13 is 1.17. So then, based on our hypothesis, or excuse me, our decision rule, which was if the test stat is greater than 1.6686, we would reject the null, or less than negative 1.6686. We would reject the null. In this case, we are somewhere in between, right? So we were at 1.17, so somewhere on this part of the curve here. So therefore, we would not reject the null. Okay, so in our part E, we would not reject the null, and we cannot conclude that the speed of play is any different. What we're saying here, in essence, is that because we are not rejecting the null, we're saying that the speed of play is essentially equal between the 2 years, not statistically significant, the difference of speed of play between those 2 years.